I kind of did the extension process.
Okay. Yeah. That's not bad thing.
No, it's not.
Because, okay, so the extension. Where do we start with number 1?
Looks like we need to find the square or complete the square so we can get vertex.
Mm-hmm.
So basically, we have to break it down.
So basically, we need to what? Sorry?
We have to basically break it down.
Yep. Yeah, so what we do, my first step always is just pull out the 3.
So divided by 3.
Yeah, so you're going to have 3 on the outside, parentheses x squared. Then you're going to have minus 4/3 x. And that x squared subtract 4/3 x, that's all in parentheses, and then the plus 8 on the outside. And then the next step, you have to multiply that 4/3 by 1/2, and then square that answer. And that should give you 4/9. Because you're going to end up, once you take 1/2 of 4/3, and then you're going to get 2/3, and then 2/3 squared is going to be 4/9. So you're going to have a new problem, that's a new equation written out type thing. It'll be the 3 outside of the parentheses still, and then parentheses x squared minus 4/3 x plus 4/9 minus 4/9 plus 8.
Yep.
Okay. And then you're going to take it, you're going to break it down further. So you're going to get 3 parentheses x minus 2/3 squared minus 4/3 plus 8.
3 plus 8.
And so then you have to find the common denominator, get everything worked out. So 3 is obviously the common denominator we want. And so it's going to end up being 3x minus 2/3 squared, subtract 4/3 plus 24/3, and then you're just going to simplify that. So it's going to end up being 3x minus 2/3 squared plus 20/3. And then from there, you're able to find the vertex. And the vertex for this one is going to be 2/3. And I believe, and then yeah, there's both positive, just came. 2/3 and 20/3, that's the vertex.
Okay. I think I got that one.
Okay. And then for the x and y intercepts, I apparently didn't. Oh, I switched to a different problem. Okay, x and y intercepts though. You can put 2/3 in as x. That's just 0. Plus 20/3. So I'm not sure because I was looking at this one on hers.
Mm-hmm.
I'm not sure where. Did you guys see or on the key?
Yeah, I did see on the key. Is it about the x?
How you get the 2/3 plus or minus I square root of 20/3?
So basically, she took out, because there was a negative into the square root. Mm-hmm. So she took it out, so that way she got an I.
Oh, Right. Okay. Oh, because you have to multiply the.
Okay.
I forget you have to multiply the 3 through.
Easy.
Yeah.
I always do that. Okay.
Okay.
So
Yeah, first. I know.
we
Well,
have
shouldn't it be
2/3
like
plus or minus
why couldn't
I
they have said I'm away at college
square root of 20 over 3.
and
Yep.
2
And
years
0.
admission, I didn't ask for anything.
The y-intercepts
Why can't people just why can't people
This one's
just
a little
hold
bit
their own
easier.
game in life and not worry about others?
pretty much just do. You look at the last. You just plug in 0 for x.
I do appreciate it.
Mm-hmm.
So it's just going to be 0 plus 8. So that's 8. So it's 0, 8 is the y-intercept.
Thanks, bud.
When you draw out, you get domain and range of negative infinity to infinity.
Mhm.
The range is 20/3 to infinity. And then excess of symmetry should be 2/3.
That's good.
Okay.
Okay, I got it.
Okay, awesome. So then number 2. Let me go to where I did this one. Sorry. Okay, yeah. So there's you're just pretty much using conversion factors.
Yep.
So what you're going to want to do is, a ball is tossed straight upward at a velocity of 80 feet per second from a rooftop that is 12 feet above the ground. The height of the ball in feet at time t in seconds is given by h of t equals -16 squared plus 80t plus 12. So
So it wants the maximum height, so we're going to want to find the vertex, right?
yep.
Yeah, we have to find the vertex.
Yeah. So you can do the vertex by using that negative b over 2a. So it would be negative 96 over 2 times negative 16. So in the end, it's all going to become positive. Mm-hmm.
Is that 42, right?
Yep.
Yeah. Should be 42.
Or the answer? Whatchamacallit?
No, that's the. Oh, yeah. Wait. I did a conversion for my one off that.
Yeah, you kind of did.
A conversion theory on my other one, rather than doing the negative b over 2a. Let's see. Oops. So t is, -3. Or no, +3, sorry. And then once you plug that in, then you can find everything else.
Mhm.
So which theorem did you use to figure that out?
So what did I use? So you do negative b over 2a.
Yep.
And so, I did 96, not 80. That's my bad. Sorry. I was looking at my problem from the homework.
Yeah, I was like, where'd you get this part? I was confused.
So, no, that's my bad. Sorry, guys.
Okay.
So, sorry, it's 2.5 for t.
Uh-huh.
Does that make more sense now?
Yeah, it kind of does.
Yeah.
So, yeah, then you just plug in for t. And then you'll have, so the maximum
Wait, 2.5.
height, yeah, because it should be negative 80 divided by negative 32.
Oh, 32, okay.
Okay.
Because 2 times negative 16 is negative 32.
Yeah, it should be 2.5.
So it should be a 2.5. And then if you plug that all in, then you're going to end up with the answer of 112. And that should be the max.
Yep, max.
Yep.
Okay. And then at what time does the ball hit the ground?
So that should be,
But
because 2.5 doubled.
oh, yeah. That should just be the 2.5.
2.5, yeah.
I don't remember if it asked about that. I think it just asked about maximum height.
That's the max.
But yeah,
Right
the
now-
112 feet is
Right.
the maximum feet. Oh, then you kind of want to use the conversion theory a little bit, and it's going to be 5 point.
Oh, yeah, because
yeah,
the building's got some height to it.
yeah, it does.
Some time to it.
Yeah, so it's like 5.15 seconds. I'm going to
Mhm.
have to look into how she got that. Because
So,
the building would add to it for sure.
well, it's basically timesing 80 times 12. Because it
Uh-huh.
says in the beginning, it says 80 of 12.
So 80 times 12?
Yeah, that's thinking. Because, well, they kind of multiplied it with 80 times 12 and divided by, it kind of was suck on.
Okay. Yeah. I may need to ask her about that one.
Yeah.
And go to the math thing on campus and ask them about that one. Because not even in the homework, it doesn't even have something in the homework like that. So
No, it didn't.
yeah, I'm gonna have to look into that a little bit. Okay.
All right.
Well then. Okay, so wow. So now we're going to be using the rational roots theorem to find the x-intercepts for the given polynomials.
Okay.
And I haven't looked into these ones too much yet. I haven't gotten to that part of the homework as much this week, unfortunately. So you guys might
Okay.
have to help me a little with these ones.
So for 3 and 4?
So for 3, A and B.
Okay. So it's kind of, so what you're solving for is basically for x. So there needs to be like 3 things for the x.
Okay.
So what you have to do, well, I can't basically, I can't show you it because it's hard on my computer, but what you have to do is make like a, it's so hard. So what you have to do is take, so when you have, hey, well, it's easier on paper instead of, but what you have to do is you have to find the zero theorem. So what you have to do is you have to find something that basically gets to 0. So for
Okay.
example, what you have to do is you have to create a, what's that called? Kai, you know what I'm talking about?
So, like, the way I understand you do it is, like, you take, like, n2, and then you find all the factors that will equal those. So, like, 1, 2, and then and 4. and then 6 itself. You have to take those, and then you have to, and they're all plus or minus, and then you have to figure out actions of them
Yeah,
too.
so okay, then all
So then-
we're trying to figure out is at the end they have to have a 0. So one of them
Yeah.
has to be a 0 at the end.
So one of them has to be a 0. So you just take all the factors. So you do like a factor tree for 6 at the end. So it's 1, 2, 3,
Yeah.
6.
Yep.
Yeah. But you have to use the 2 under the factors of 6, and it makes fractions, and those are also part of your.
So you have
You
to
get
use
the
the 2
1/2.
under the 6.
You have to stick the 2 under the 1, under the 2, under the. So like all the factors, you also have to make them fractions, but you use the first number in front of the x as denominator.
Okay, okay. That makes sense.
So-
You'd have like 1/2 for one of them.
Yeah,
Yeah.
so for example, like for number 4, you have to use a fraction to figure that one out.
Mm-hmm.
And then for 3, you have to use -2.
Yeah.
Okay.
Does that make
But
sense?
I'm not sure if you just at that point just test them and see which ones work,
Uh-huh.
or I know that it gives you those. Like I know that part, I've figured that out, but I haven't figured out exactly what you're supposed to do with them when you get them.
So the goal was, I think what the teacher is trying to expect is what can you do to get the 0, and then trying to break it down into finding out the 3x theorems. So that's why I kind of figured it out last night.
Okay. Okay.
So looking at it, I think we can just use all those numbers we got and see which ones give us our zeros.
Yeah, so I'll help you out, Caitlin. So
Okay.
so what you need to have is parentheses x plus 2,
Mm-hmm.
and then what you're gonna have next is parentheses 2x squared minus 7x plus 3.
Okay. Sweet. So
Is that a simplified version of the fraction?
Yeah. Well, then you break it down 2x squared minus 7x plus 3.
mm-hmm.
So what you're gonna have is x plus 2, then 2x minus 1, and then x minus 3.
Okay, and that's how you get. Okay, that is a lot easier.
Sorry, I hate explaining it in my own words because
No,
you're on the paper.
no, I get you. I'm the same way. So that makes it so much easier. So it's the zeros are -2, 1/2, and 3.
Yep, and that's the answer.
So it's going to be
How
negative
did you
2
simplify
zeros.
the fraction?
So you mean you're talking about 2x squared minus 7x plus 3?
Yeah.
So what you have to do is you have to make it into 2 brackets. That's kind of the goal. So when you have like 2x squared minus 7x plus 3, all you have to do is what things can you multiply to get that? So you should have 2x as one of them on the left. And then on your next bracket, you should be having an x. So that's why if you multiply it by, or
So really what you did is you just pulled an x out for the 2x cubed out of 3x squared. He pulled that out to get that x plus 2, and he got the x plus 2 because 2 times 3 would end up equaling
positive
6
3.
again.
Yep. So what I'm saying, Kyler, is that what I did is was 2x minus 1 and x minus 3. They both have to basically get 2x squared minus 7x plus 3.
Okay.
So did that make sense?
Yeah.
Okay.
So what did you like? So did you put the 6 on the other side of the equation and then pull the x out or
What
something?
if I just skip my class today?
So like, what do you mean?
What if I just skip my class today?
Because isn't the starting problem 2x cubed minus 3x squared minus
Why is
11x
this
plus 6?
Yeah,
Or
that's
am I
kind
reading the
of.
wrong problem?
Oh no, you're right. So
Go from there. That's what I'm having trouble with.
okay, so when you see that x cubed, you see that x
Yeah.
cubed. So what you're gonna have is 3 answers
Then
for your
Yeah.
x.
yeah, me too.
So what you need to do is you try to break it down so that way you can get x 3x intercepts,
Okay.
because that's kind of the goal of the problem is to get 3x intercepts.
Okay.
So when you get to, like, for example, like I explained to Caitlin,
This is a
that
little early with the
x
pictures.
plus 2 with the bracket with 2x squared minus 7x plus 3. So you're trying to break that down so that way you can get 3x intercepts.
Okay.
So then after that, break that down so we'll get x plus 2 and then bracket with 2x minus 1 and then x minus 3. Because your goal is 2x foiling to get 2x squared, and then minus 1 with minus 3, it'll give you a positive 3.
Okay.
And then once you've done that, then it's kind of the zero theorem. So
Mhm.
everything. So basically, after that, you take x plus 2 equals 0. You take 2x minus 1 equals 0. And you take x minus 3 equals 0.
Uh-huh.
And once you've done that, then you find your x intercepts.
Okay.
Does that make sense, Caitlin?
Yep, it does.
Good. I'm a math teacher.
Good job, Nate. Thank you.
You're welcome. That's for 3.
Sweet. Okay, so we have that. Do you want to go over the g of x problem, Kaylor?
Okay, so cubed minus 8x squared minus 8x plus 8.
Mm-hmm.
So we need to reduce it down. So what would that be? What can you like reduce that to?
So you're trying to figure out what can you put into the x something.
Oops.
Yeah, like we can use the 3 and the 8 and we can put like 1, 3, and it looks like probably 2,
Mm-hmm.
4, and 8 into it.
Yep. So you have to
And-
decide.
And then we'll have to do and then I think you have to do 8 over 3 too for fractions.
Mm-hmm.
That's all of our possibles.
Yeah.
And then on simplifying this fraction, I still like understanding what's the best way to break them down the fastest.
So you're gonna want to pull out an x first, and then.
Okay, so you just divide it by x.
Mm-hmm. And then
3x
that-
squared minus 8x. 8
Huh.
plus 8 divided by x. Is that how that works?
yeah. Yeah. Because, well, pulling the x out would just kind of get rid of all the x. So it'll just be 8 by itself still.
Okay, so it doesn't divide by that one too.
Mm-hmm.
No.
Okay.
Like, I guess you could, but it just makes it kind of weird.
Yeah, it kind of does.
'Cause you're just getting rid of the x. And since
That's
that one
right.
doesn't have an x with it, you don't need to divide it by x.
So never mind.
And so then
Never mind.
cancel, right? So it's 0. So then you can just. Or, let me think here.
Yeah, I didn't think about that.
It'd be 2x.
Oops.
Times would be 0. So what is it? 2x minus 8 or something, and then just x.
Let me see. So I want to pull out the x. 3x squared minus 3x minus 8 plus 8. Yeah, those 8s would just cancel out.
So it's like 2x minus 8 x plus 0 or something.
Yeah, so
I don't know what's the best.
I have like if those 8s cancel out, it would be x 3x squared
Oh,
minus
sorry, 3x.
8x. And then yeah, I just end with that because you don't really need the plus 0.
Mhm.
Yeah.
And then at that point, you can kind of work it out. So what is going to add up to be, or what's going to subtract or add to be negative 8x? And then you're going to want 3x in one and x in the other. And then decide you're going to want a plus and a minus to make it negative.
Mm-hmm.
But you're going to have to know where to put them and kind of guess and check with at this point.
Right.
Well, where it's a plus 0,
Mhm.
that's going to be like our time side. So I'm betting is like x plus 1 or x plus 0, because 0 times anything will make it 0.
Mhm. So it's just going to be the x.
Yeah. So I think one of the equations is like just x.
Mhm.
Probably x plus 0. You could write it that way, and then so
Yeah.
pretty much
And then just make it the x.
this is 0, 0.
Mhm.
I'm assuming. The other one would be like 3x minus 8. And so if you times that, the 3x times x gives you your 3x squared. The negative 8 plus 0 is just negative 8. And then negative 8 times 0 gives us 0.
Yeah. Let's see. Okay. Yeah. So her answers are interesting on that one.
So are you guys stuck on something?
Yeah.
Okay.
So I don't think I did it right because it's not like matching up with like what she's got.
Yeah, not at all. So I don't know. But what he did makes total sense to me.
So I already figured I got that. So you want me to explain?
Yeah.
Okay. All right. So it's just basically like that table, like what's something you can plug in to get the zero theorem. So what you should have, because this one's kind of a little bit different from number 3,
Mhm.
you should be having 2/3.
And where do you get the 2/3 from?
So what you're trying to do, like for example, back to with the box. So Kyle, you remember that thing that we did for number 3 with that box thing, with that trying to get one down and then I can't explain it right. So what I kind of did is I kind of break it down. So with that 2/3, the reason why I got it as a fraction because I knew that any numbers that I could plug in
Mhm.
could not get 0 at the end. So I was thinking of what's something both have in common with 3, 8, or 3, -8, -8, and then 8 is kind of a fraction, fraction. Because I could put any number in, but it won't work because I tried and I kind of failed.
Okay.
So you just kind of put some numbers through it rather than simplifying.
Yeah, so instead of basically I did is book, I did a fraction because there is going to be a fraction in one of the problems. So I put in, after I made my box and created that, you should be having x minus 2/3, and then parentheses 3x squared minus 6x minus 12.
What was the second one?
3x squared minus 6x minus 12.
So you put it through the synthetic division or whatever it is.
Yeah, I put it in the synthetic division because
Okay.
Caitlin, like when you plug in like 1, 2, 3, and 4, I did that for every single one, but it did not give me a remainder of 0.
Yeah.
So instead of doing numbers, I tried fractions, and one fraction I came out with is 2/3 to get the remainder of 0.
Use that. I'm guessing to find the next one.
Yeah. So the x minus 2/3, 2/3 is
One of them.
Yeah, is one of them. So for this one, it's kind of hard to explain. Like, you have to use negative b plus or minus the square root of b squared minus 4ac divided by 2a to get
So you have to use the quadratic formula.
Yeah, you have to use quadratic formula if you're going to get that answer.
Okay. Okay. That makes sense.
Sorry, that took me all night to figure that one out.
No, yeah, that would have taken me forever too.
Yeah.
That's an intense one. Holy cow.
Wow.
Does that kind of make sense, Kyler?
Yeah. So you had to use the quadratic formula to finish it off.
Yeah, because the problem with 3x squared minus 6x minus 12 is hard to reduce. So what I decided to do is use the quadratic formula.
Okay. Yeah. And you got it that way. Here you go.
So you had to use synthetic division and the quadratic formula to simplify it enough to get one answer.
Yeah. Yeah, it kind of does just a little bit. I just hate quadratic formula.
That's
Dang.
yeah.
I hope we don't have one of those on that exam because I'll fail.
Yeah, I would
That's
fail
like
too.
an intense problem.
Oh, I would.
That's insane.
To take that long on one question on that big of a test would be just terrible.
Yeah. So did everyone?
Okay.
Or never mind. I just.
Oh. Yes. Thank you so much, Nate. That helped me a lot. I think I got it down now. I just gotta
Did that make sense?
really use guess and check sometimes.
Yeah. I just kind of go with the flow.
Yeah. I like it. Okay. Let's move on to the quiz.
Okay. I haven't done the quiz yet because I knew it would be everyone.
Yep. Me either. I saved it this time because I have some time.
Okay.
And just looking at it, I was like, okay, there are no numbers on some of these. This is going to be interesting.
Yep.
Okay. So can y'all see this? I pulled it up.
Hold on. Yeah, now I see it.
Okay, sweet. So, first problem we have to find the x-intercepts. Of the quadratic equation y equals ax squared plus bx plus c by completing the square. So I can't decide if like numbers or an actual equation was just left out, or if this is really what we're completing the square for.
I think that's really what she wants us to complete the square for. I think
I'm
it's just
pretty
going to
sure.
end up being letters.
Yeah,
Is it gonna be letters?
yeah, that's
That's my-
what I got. So, my guess is you just start by pulling out the a like you would with anything when you're completing a square. You're always going to want to pull something out.
So that means you
Alright,
just
so
divide the whole thing by a?
Yeah. So it would be a x squared subtract b over a x plus c.
Yep.
And then here's where it gets weird, I guess. Because you're then going to want to take b over a, multiply that by 1/2. So that would be b over 2a.
B. I think you're right. B over 2a.
So,
First, so you pulled a out, but how did that affect b again?
So
So-
you're going to end up with a, and then in parentheses, x squared minus b over a, and then the x,
Yeah.
and then parentheses, and then plus c.
Okay.
And then you have to multiply to get what your, I don't know, what's now going to be in the parentheses, which is an x and then squared. You're going to multiply
Okay.
ba times 1/2. So
Okay.
whenever you're completing the square, that second part in the parentheses, it's always going to end up a fraction. You're always going to multiply that by 1/2.
Oh yeah, and then you gotta square it, right? And then
Yeah.
on the other
mhm.
side.
Yeah, and then once you square it, you do plus minus, and then you have whatever that is plus c. So, but in the parentheses, you just have the, when you first multiply by the 1/2, you have that, because then when you square it,
Okay.
because you're going to square the whole parentheses.
B over 2a.
So it's like it comes out a parentheses x squared minus b divided by a x parentheses and then like 1/2 times by
B over
a.
Yeah, so
That should get
so
you.
actually it's just going to be plus c for now. And then you're going to, once you get the plus c, so that's like the new equation, then you're going to take that ba and multiply that by 1/2. B over a multiplied by 1/2. So you should get
Okay.
b over 2a.
Yep.
And then if you square that, so that b over 2a, that's what's going to replace that b over a in the equation in the end here. So anyway, but you're going to square it, and that's what you're going to have to deal with it a little bit. So you get b squared over,
4a squared?
yeah, that's what I would, yeah, say 4a squared.
Okay. 4a squared.
Right.
Okay. And then 58 squared minus b over ax.
Okay. So then, once you have that point, you're going to rewrite it again. So you're going to have a parentheses x subtract so in the end, you're going to want a plus and a minus. Oh, that's going to be it. Okay, there we go. So it's going to be x subtract b over 2a parentheses squared. Well, I kind of just skipped a step actually. So really what you would do, you go a equals x subtract b over 2a plus b squared over 4a squared minus b squared over 4a squared. So in the end, that just cancels out. So it's just the a x minus b over 2a squared. And then subtract, I believe you just subtract the original. So just the b, yeah.
Huh.
Right? Because in the end, that would just become a b over 4a because those squareds would cancel out.
I still have that question about if multiplying 2 with a squared can actually that work.
So 2a and 2a.
Yeah. I never
I
heard
feel
that.
like it should just be,
Never heard that.
so you go like this. You have b times b, so that's b squared. And then 2a times 2a should be, I would just say it's 4a. But, Kayla, what are your thoughts? If you were multiplying b over 2a times b over 2a, would you put a squared after the a, or would you just leave it as 4a?
I think it should be squared. Because
I
if
think,
let me think here. Because if you had a regular fraction like 2/4 times 2/4, it would be 4/8, right? No, it wouldn't.
No.
it'd just be 4/16.
It'd be 4/16.
Oh, wait.
Fourth. This is why I like numbers a lot more than letters.
Oh, it sucks. Okay.
Because if it's both squared in the end, then the squareds are going to end up canceling each other out, so it would just end up being b over 4a.
B over 4a.
Does that make sense? Because if you square it, so it becomes b squared over 4a squared, the two squared signs,
Yeah.
top and bottom, end up canceling each other out.
So basically, you'll have like b over 4a. That's
Yeah,
what I'm saying.
does that make sense?
Yeah, that kind of
Yeah.
makes sense.
Okay.
So just like a regular fraction where the top stays the same, but the bottom
Yeah.
increases.
Okay. And then you have a plus c.
Yeah. So,
Ooh.
and then you're gonna want to take, I believe it's the original that you take, the b over a, subtract the b over a plus c. So, that's the part I always get lost on, unfortunately.
Let's see.
Because on some things it's like, okay, like, oh, it is b over a. Oh, I'm pretty sure. Because I'm trying to think back to the homework. And if you look back at like the homework, let me see if I can pull up the textbook really quick and kind of
Okay.
look at what it says.
Two. So
Sorry, I have to pull up a bunch of different screens. Okay. So go look at this. Because like on the one in the equation, you just take the original, which is 4/3. like on the extension problems.
Yeah. But kind of the problem is that well, the problem is with C, they have to be the exact same thing.
Mm-hmm.
So, and I was like, okay, I'm kind of lost just a little bit.
Let me go back to where I have to complete the square more. Okay, like on this one. This
Okay.
one. Oh, holy cow, this one took me forever. It was number 4 on the homework. Let me view the example. It literally, I don't know why it took me so long. Oh, because I kept accidentally putting x squared in the parentheses. I remember. Okay, yeah. So then you're going to take it. Let's see. So in the end, sorry, just looking at some stuff really quick.
You'd be having 49. Greatest common factor.
Yeah, so yeah. So it gets funky. Because in some parts, I don't know. In some equations, it's like, oh, you just use the original. In others, it's like, okay, you took what you squared and suddenly you do something else. It's like,
Wait, never mind.
oh. See, like if you're looking at this problem right here, I don't know. Could you guys see when I was looking at the example?
Yeah.
Because that's what I'm. Okay. Textbook.
I still wonder.
I have it.
I still wonder that. B minus B over 4A plus C.
Yeah. I wish I could do more at this part, but for some reason I always get stuck at this part.
Okay.
Okay. Because yeah, see, like this is, they just added the A pretty much. So we want to get it in this form. And then at that point, we could find H and K, which would be the x-intercepts.
Yeah.
So let's see. So example 1 of completing the square. Okay, yeah, see? So pretty much we take, it's easy to convert this to the form of this, but we're taking this and converting it back to this.
So you're kind of saying that we need to find greatest common factor?
Yeah.
Okay. Because I still wonder if the greatest common factor I was thinking of is 4AC.
It's like part of the quadratic formula.
Kind of. Kind of.
Textbook. But the examples don't help with time. Okay.
Don't explain it with letters.
Okay, so let's see. So x squared plus bx, x squared plus bx plus b over 2 squared. Okay, so really what it is going to be the x squared, which we have, plus the bx, which we have.
Yep.
And then that c came from b over 2 squared. So let's see. So k is going to come from b over 2 squared. Or is that wrong? So for a,
Because we're gonna have B over 4A plus C.
it's like here's the example with the textbook, but that one is super easy. I like those ones. These ones are just so nice. They don't deal with fractions like at all.
Yeah, with numbers, okay, I can tell what the greatest common factor is. I just with letters, it's throwing me off just a little bit.
Yeah. See, like, because the examples, they're so nice, but we are always having to work with fractions. So it doesn't make it so nice.
Wait. Wait. So I was kind of looking back at the problem with number 1.
Uh-huh.
What do you? So I was thinking of
Oh.
maybe because going back to number 1, I was looking at how they got 20/3.
Uh-huh.
So I was looking at was it 4 ninths? Was it 4 ninths? Oh, wait. Yeah, 4 ninths. So I was looking at this and I was like, huh, that's very interesting. So
Oh my
somehow,
goodness. Okay, yeah,
do
go
you
ahead.
see? Do you see that? Okay, so what I was thinking of, maybe they kind of reduce that down just a little bit. So they put a 9 at the greatest common factor. Maybe the greatest common factor for both is 4A.
It is for a. Mm-hmm.
Oh, who's the genius? I am.
It is the greatest common
Smartest
factor
man
is
in the world.
indeed for a. And you're going to end up subtracting. I think I got it. You are going to end up subtracting. You're going to keep that b squared, but that other squared disappears. The 4a.
Okay.
So it's going to be a x subtract b a over 2a squared. And then you're going to have subtract b squared over 4a plus c.
Okay.
And then at that point, you have the greatest common, yeah, so it's going to be 4a. Because that's stupid. Okay, it's not stupid, it's just frustrating. Okay, so now we just have to, end up combining those two. So it's going to be, let's put c over 4a. So, yeah, shouldn't it be once you combine them? You do,
Oh.
because now combining them is going to be weird. So it should be a x minus b over 2a squared. Then it's going to be,
Minus?
I think it should be plus, I'm pretty sure.
Okay. Yeah, it's gonna be a plus.
Yeah,
Yeah, I think it's probably gonna be plus. That's my guess.
but then it's almost kind of like they cross multiplied here a little bit. Rather than, because then if you just, okay, so if you add those two together, you now have all over 4a.
It should be CB.
Then, yeah, it would be,
CB over 4A.
the c over
Wait, we're
4.
looking for that x-intercept, right?
Yeah.
Yeah.
trying too hard.
What?
Because in the book it says we can use the equation negative b divided by
Over
2a.
Yeah.
Negative.
It should be negative b over 2a, and that will end up giving you the vertex or the intercept in the end. Yeah.
Okay. So
We have negative 20 thirds. How do we reduce that?
I just saw like kind of an example in the book. Like it almost gives you this whole problem in the book, pretty much.
Okay.
But I'm lost, which is weird. I don't know why she would do that. She's like, you can use your textbook, and look what I just found. Okay, I literally found our problem. So we're supposed to end up getting, once you add that negative b squared, so you have that negative b squared over 4a plus c, you're supposed to get 4ac minus b squared all over 4a.
I'm kind of lost.
Yep, me too.
I'm kind of
Totally.
lost too.
Because that's the part, okay, so you remove, oh my goodness. Okay. So, one moment, let me,
Because you're right. It should be having a parentheses x minus b over 2a squared. I got that. Where did you get that? That's
do you
kind
see
of...
this? Look.
Oh! Oh, you cheater, pumpkin eater.
I'm not, I'm using the textbook like she said I could. I'm just looking, and now I'm lost. I went
Oh!
to the next page, and I was like, it's literally right here.
Oh, I thought you were cheating. I was like,
No.
this is a quiz.
But I feel like that's what it is. I was like, it's literally sitting right in front of me in the textbook, which I'm allowed to use.
Okay, fine. Fine.
Which kind of weirds me out just a little bit.
Yeah.
And I feel like I shouldn't be using this.
Well, yeah, you gotta be careful, because if the teacher saw that, then we'll probably be cheating.
Yeah, it's weird. So, I'm just gonna get rid of that. Okay. But yeah, so, I mean, I don't know how it would be cheating, considering that we are allowed to use the textbook. And I feel
she
like
probably got the problem from the textbook.
she probably did.
You
Like,
probably
literally.
did. I don't know why that's only a quiz.
That kind of like,
Yeah.
whoa, freaked me out. Okay, yeah, you can only use your textbook notes and calculator on these problems.
So we just find that. So we just find the answer.
Yeah. So once you get all that, because then I guess I didn't add every single little part to it, but
Okay.
I'm confused on where she gets the 4ac minus b squared.
4ac minus b squared. So can you pop that up again?
Yeah. Let me go back to it and pull up the textbook again. Sorry, one moment.
So looks like they're removing the b squared over 4a squared, like minusing it from inside the parentheses,
Uh-huh.
and then when b squared over 4a squared minuses from over 4a, that gives it the 4ac minus b squared.
Okay.
I'm not sure how that works.
Yeah.
Yeah. So basically, we need to go back to that screen.
Yeah.
Sorry,
Slowly
I'm
but surely.
not.
Okay, so let me go to the next page. Okay. Yippee.
Let's go. Yeah.
Okay, here we go. So is it back up for everyone?
Yeah.
Yeah.
Okay.
Oh wait. Let's see. 4ac minus b squared.
So yeah, because so we did have it. So it is 4a squared, but then you just like take the negative b squared over 4a, pull it out of the equation. And then
Okay, yeah, right.
factor
So the
the
greatest common
common-
factor is 4a
Yeah.
for both of them. And let's see. I can know this. Oh no. I'm having a brain fart. Because we're gonna have 4ac.
So, but in our case, would we end right there, or does she want us to go all the way down to that h plus k? Because that doesn't exactly make sense to me.
Yeah, I was like, did she actually put a random k?
Oh, so just h, I see. So let h equal b over 2a squared and k equal 4ac minus b squared over 4a.
Because yeah, I kind of feel like the teacher is actually putting like random letters into that, so that's why she got a parentheses x minus h squared plus k.
Oh, yeah.
That's why I feel like
this
that.
is the book example. So the h plus k, because that's what it's like. So if you go back to page, if I were back on page 187, it would have you going from the form we're now in, or no, sorry, from the answer a x minus h k to the ax squared plus bx plus c. But in this one, we're going from the ax squared plus bx plus c down to the ax minus h squared plus k. So really, pretty much, we're just, when we have our b over 2a and our 4ac minus b squared over 4a. So b over 2a, that is our h. So we just replace that with h. And then the 4ac subtract b squared over 4a, that's our k, so we just replace it. So really, we're just replacing things now. So then in the end, it would just be a equals x minus h squared
Plus k. Okay.
plus k. And that's our answer.
Okay.
Heck.
Yep, that's
And so that's the x-intercept?
yeah, and so now to find the x-intercepts.
Okay, I see what you don't know.
So
Okay,
now
and then,
we just gotta find that x-intercept.
Yep.
For this one. And that's the problem.
yeah. So let me go back to the screen share.
So I still don't understand how they got 4ac minus b squared.
Me
over
either, because
4a.
I'm trying to find, because she pulled it out. Like, the only thing I could think is if they, like, cross-multiplied the C and the 4A.
Oh,
Yeah.
I think no. Because I was thinking if she puts 4a squared, but that one.
Because what
That
you would
just-
have to do is, if they... So put C over 1 for a moment, you know?
Okay.
So it's like negative B squared over 4A plus C over 1. So if... No, that wouldn't work, because if you cross-multiplied, then you would have 4ac
So basically,
subtract b squared, but then you'd have over 4ab squared. So that wouldn't work. So you have to find the common denominator first, and then cross multiply. I don't know. You're
So
having
they-
to cross multiply
Are
somewhere.
they timesing them or like adding them or what are they doing to them?
Yeah.
Oh,
You're adding them.
yeah, you're kind of adding them. So, I think I probably figured it out. How she got that, or the textbook, whatchamacallit.
Okay.
So you see that 4A right there.
Uh,
So they
This-
somehow
this one.
with 4AC minus B squared all over 4A.
Uh huh.
So when you take it out, your greatest common factor is going to be 4A.
Okay.
So what you have to
Oh.
do, because when you have a 4A and over B squared, you leave it because that 4A is the greatest common factor. Should be minus B squared.
Okay.
So with 4A, you take that and you'll have 4AC minus B squared all over 4A. And that's how you got that.
Okay.
Because B
So-
squared and 4A is, oh, no.
No, go ahead.
I'm talking too much.
No, you're doing great.
Okay, you want me to explain why they got that?
Yeah.
Okay, so in my own words. So the reason why they got this, because they're trying to find the greatest common factor with all that. So they took the bottom of 4A, because that is basically the greatest common factor, and C is 1. So what they did is they took 4A as the greatest common factor, and then they did that for the whole entire thing. So they have C over 4A, and then you do that. So you multiply the 4A to the C, you'll get 4AC, but you leave the minus B squared all over 4A because that is basically how you get 4AC minus B squared all over 4A. Did that kind of make sense?
So what did they do with the B squared over they took out of the parentheses though?
Minus B squared. Oh. So because
So
you
I'm
should
following
be
you on what you're talking about, but
okay.
they did with the rest of it.
I'm trying to explain this to you. So it's hard to explain it because I like writing it down. So mostly you're trying to figure out. So the next step is to trying to find the greatest common factor, Kyler. So what do these all have in common on the numerator, whatchamacallit, denominator?
Yeah.
So
So you end up timesing C by 4A, obviously.
yeah, so you get 4AC.
Yeah, 4AC. Negative B squared,
Oh,
A
4A.
squared, right? Over
Yeah.
4A squared,
Mhm.
minus by B squared over 4A.
Yeah. The question is, why is there a plus? Is that what you're asking me?
So like what happens when the B squared over 4A squared is minus by the B squared over 4A?
That is actually a really good question.
So what was the
So does
question
that
again?
become
Sorry?
so like because they're taking B squared over 4A squared,
Uh-huh.
and then when you write that out, you get your minus B squared over 4A squared over 4A plus C, and then we can obviously make the C 4AC over 4A.
Uh-huh.
When you minus those, that should make it like, what is that, like 2B or something? I don't understand how the I'm assuming it becomes 2B. Negative 2B squared or something like that.
Yeah. It'd be negative 2B squared. But
And
Does
then
that-
just be, yeah.
Because I know how they got 4ac minus b squared all over 4a, because they took the greatest common factor, and you should
Yeah.
be a positive at the end. Because,
Yeah.
for example, with 20 over 3 as a positive, I think that's why they got a positive at that, because it's 4ac minus b squared all over 4a.
I'm just curious what they did to it to get the negative b squared over 4a in their math of doing the fractions.
Yeah, I still wonder that myself. But it's mostly kind of breaking it down with the greatest common factor.
Yeah.
So it should be having like 4ac all over 4a minus b squared all over 4a.
Mhm.
So it's kind of the same thing as 4ac minus b squared all over 4a.
Okay.
Does that kind of make sense, Caitlin?
Uh-huh. Yep.
I've been talking too much.
It's all
No,
good.
you're good. You're great.
Oh.
Okay.
All right. Should we move on to number 2?
Yeah,
we
let's
should-
do it.
I hate it. I hate it so much.
Okay. Let me get back to the quiz. Pull it up on screen share. So this is just using the zero theorem.
Yep.
So, yippee.
Oh.
We have somebody that's really good at this.
What are you guys looking at me for?
Okay. So, here it is. Oh, so we gotta do the x-intercept and then the y-intercept. The x-intercept for it, it's just gonna be the h and k, I'm pretty sure, right? Or is it 0?
It just says
So we have to complete the square to find the x-intercepts.
Yeah, we have to complete it. And
There we
then
So the x-intercepts should just be h and k, right?
I think so.
Or would it be h and 0?
It should be h and
it
0.
should be 0 because it's an intercept.
Yeah, because of the x-intercept.
Or 0h, whatever.
Because 0
Got it.
and h is y-intercept.
Yeah, because then if you plug in 0 for everything, then y should just be 0, 0, right? Because you just have to plug 0 into the equation. So everything being 0, y would just be 0, 0.
Yep. So it's at the vertex.
The vertex would be hk.
Yeah.
Okay. So are both of them 0, 0 then?
Well, for x, it should be, you're going to want to, whatever in the parentheses would make, so x, just replace x with h, so h equals 0. Or would the x-intercepts be hk?
Or do we
Yeah.
want to put in the b stuff?
Because the x-intercept, the x-intercepts might actually be hk.
Yeah, it's hk.
I'm pretty sure, because the vertex and x-intercept kind of same thing, right? X-intercept would be what? For the equation ax minus h squared plus k.
The x-intercept? What was your time?
Okay. So we have the x-intercepts. We're plugging in 0 for x.
X-intercepts? Y needs to equal to 0.
Because y has, okay.
Y needs to be equal to 0.
So y has to be equal to 0 for x-intercepts.
Yep. Basically, y is going to be 0.
So yeah, So ax minus h squared plus k all has to equal 0.
Yep.
So 0, 0 would make sense.
But for the x, problem is there's gonna be 4 answers.
Yeah. Okay. Let's write it out. So it's gonna take a little bit of room. So 0 equals a x subtract h squared plus k. And now we need to get x by itself.
So we can just minus k first, right?
Mm-hmm. So negative k equals a x subtract h squared. And what you're going to want to do next is divide by a. So negative k over a equals x minus h squared. So then you're going to want to take the square root of both to get rid of the squared. So it's the square root of negative k over a equals x minus h. So then add the h over.
Huh.
Oh me, oh my. So then it's going to be the square root of negative k over a plus h equals x.
So when we're writing that in as our answer, imaginary, and make it I over a plus h,
Yes.
Mhm.
get rid of that negative.
Yep. I square root of k over a plus h equals x. So then the x-intercept then should be well, because then you could do h plus or minus I square root of k over a, right? And then 0.
Yeah.
Yeah.
And that is our x-intercept right there.
Yep.
And then y, you just plug in 0 for everything. So y is still just 0, 0.
Yeah, it would be 0, 0.
And now we are done with problem 1. Holy cow. Okay.
That was a pain in the butt.
Yeah, it was.
Oh, that was giving me a headache. Oh my gosh.
Okay, now number 2, it's simpler.
Oh, okay. Now that's easy. That's so easy.
2x
The fourth.
the fourth subtract 5x cubed plus 6x squared minus 15x. So what has to be done before we can use the rational zero theorem to find the x-intercepts?
So what can you do before you use that?
We just got to take out an x, right?
Yeah.
Yeah. Yeah, I think we need to take out the x.
Or would you pull out, in this case, 2 x's? Well, no, because that wouldn't work, because that doesn't end with x squared. Never mind. Yep.
Yep.
Yeah, it has to be an x.
And then you get like 2x cubed minus 5x squared plus 6x
Minus 15.
minus 15. An equation we can use.
Yep.
Yeah, that's the equation.
Yeah, they don't have aux. You'll need to get new headphones or something.
And then we just go to B, right? That's A, right? That's the answer to
Yep,
A.
that's A.
That's A.
Cool.
The B is trying to find all the real and imaginary numbers.
Yep.
Okay, it's gonna be fun. It's basically talking about 3 and 4 of the extraction problems, extension problems. This would take forever.
Yep.
Oh, great. Oh,
So 1, 2, and
3.
do we have to do all the factors of 15 too? Or just that both of them? 1, 2, and 15 or something like that. Wait, 1, 2.
And 15. So we have to
Yeah.
find a number that basically ends with a plus 15.
Yeah. Or negative 15.
Yeah, dude. Sorry, my fault. It has to be a positive 15 at the end.
Yeah.
Or, you know what I'm saying? Yeah, never mind.
Yeah.
So we'll have 2, 5, 6. I hope there's not going to be a fraction, because that would take forever.
Yeah.
Be 2, 2, -3, -3, 3. Nope, 1 doesn't work. So let's try 2, 5, 6, -15. 2, 4, that'd be -1, that'd be -2, that'd be 4, 8. 2 doesn't work. Let's try 3. 5, 6, -15. 2, 6, 1, 3, 9, 27? What? Dang it. 1
Caitlin
through
just
3
dropped
doesn't
out of the
work.
call.
Oh, dang it.
Caitlin's laptop just freaked out, so she had to drop out of the call.
Okay. So let's,
I wonder if she can connect on her phone or something.
yeah. So 1 through 3 doesn't work because it doesn't give me a 0 at the end.
Yeah.
So I'm going to try fraction really quick.
What fractions did we have? Would it be 15 over 2? And what, like 5 over 2 or something?
15. So remember we talked about things that can basically get 1, 15, 1, 15, 3, and 5, and then 1 and 2.
Yeah.
So I was kind of thinking, 1. I can't do 2 things at the same time. 1, 2. So we'll have a plus and minus 1, a plus or minus 2. We're gonna have 15 halves. I mean, if you want to try 15 halves, that'd be great. And then plus or minus,
Oh, right.
yeah. So 3 plus or minus 3 halves, and plus or minus 1 half.
Yeah.
So all of that has to be 0, and that's the problem. It could be any one of those.
Yep.
So, so I'm gonna try 5 really quick. 6, -15. So that would be 2, 10, 5, 25, 1. No, 5 doesn't work. I'm going to try 1 half. Half. 2, -5, 6, -15. Be 2, it'll be 1, -4, be -2, 2, 1, -4, -2, that'll be 4.
Well, 15
Damn.
halves.
Nope, 1/2 doesn't work either. Dang it. I'm gonna try 3 halves. See how that goes. Because either way, that has to be 0. There
Yep.
has to be. 2, 3, -2, -3. No! Stupid fraction. 2, that'll be -2. That would be -3. That would be 3. That would be 9 halves. That doesn't give me. It doesn't. 3 halves doesn't work. Okay. 15 minus 9 divided by 2. That's 10.5.
Or 1/2 doesn't work.
5 halves. Try 5 halves. 2, -5, 6, -15. So it'll be 2, it'll be 5, it'll be 0, it'll be 0, 6, 15. Oh!
Is it 5? Is it 5 halves?
It's 5 halves. It's 5 halves. Thank you.
Last one we tried.
It's 5 halves.
But-
So
So we can use 5 halves to do synthetic division now, right?
yeah. So we'll have x minus 5 halves